Okay, so what we've got then is kx squared plus 4kx plus 3 equals 0. It has no real roots, and we will prove that k is bigger than or equal to 0 and less than 3/4. All we're also going to do, you got no real roots there. We know we're going to be looking at the discriminant later on. Now what's caught my eye is this bit here is saying that k is bigger than or equal to 0 and it's less than 3/4. Now usually when we got stuff like this, usually this is just bigger than and less than, but what's caught my eye is this is bigger than or equal. So what I was thinking is if we put k is 0 in here, of course 0 times x squared will go, 4 times 0 times x will go, and you're left with 3, which is 0, and of course that can't actually work. That can't give any real roots, and I call this proof by contradiction. It's not providing any real roots because 3 can't equal 0, so we know that k equals 0 is a possible solution here. Now of course if we go back to what we've done previously, we know we're after a discriminant and we want b squared minus 4ac is less than 0 because there's no real roots. And we know that a is k, b is 4k, and c is 3. So what we're going to do is we're going to plug this all in. Now I think this usually helps students as well, because we've got b is 4k. It's quite helpful to put 4k in brackets square, because then you know you're squaring the whole thing, because some people have left that as 4k squared in the past, which has caused lots of problems. So obviously 4k squared will give us 16k squared, minus 4 times k times 3 will give us minus 12k, and this is less than 0. And of course we want to obtain some critical values really, so we want to find some solutions for k. So I'm going to put it equal to 0 now, and then we're going to work out which way round the inequalities go by using the graph as we've done in previous homeworks. We've got k in both things. We know we're going to pull a k out. 16 and 12, there's a common factor there of 4, so I'm going to pull out 4k. Do that. So 4k equals to 0. So we know k equals 0, that's a critical value, and we've got 4k minus 3 equals 0, so 4k equals 3, so k will equal 3/4. So these are critical values, these are not our actual final answers. We're not saying that k is 3/4 etc, we're just saying that these are the two roots on the graph. We want to work out which way the graph goes. So, having said that, extend that bit. We know we've got a root there at 0 and a root here at 3/4, and because it's a quadratic we know it does that. Now we're told it has no real roots, so it's less than 0, so we know we're looking below the axis, so we know we're looking here, going between these values. So usually we'd say here, yep, k is bigger than 0 and less than 3/4. However, we made a statement at the beginning, using proof by contradiction, that when k is 0, this produces no real roots. So we take that into account as well. We can say that k is greater than or equal to 0, but less than 3/4.